Today we are talking about experimental versus theoretical probability. We're going to start with a refresher on how to count using permutations or combinations. First warm-up, how many ways can you arrange 3 different vans, 4 different SUVs, and 2 different sedans if they have to be grouped by type? Well, remember that those 3 different vans can be arranged 3 to the factorial ways, 4 SUVs, 4 factorial, and 2 sedans, 2 factorial, because there's all those different ways that we could arrange them. And then if they're going to be grouped, I can take the vans, the SUVs, and the sedans and have those in 3 factorial different ways. Or when I multiply all those together, I get 1,728 ways. How many ways can you select a committee of 4 from 5 executive and 3 sales reps if you have to have at least 2 executives? Remember, at least 2 means there needs to be 2 or 3 or 4. The most efficient way to look at this, of course, is in the, words are hard, the reciprocal way. So the top, we would have 3 numbers to add together. The bottom, we could look at the no restrictions minus having 1 executive and 3 sales reps. We can't have 0 executives because we don't have enough sales reps to have a committee of 4. So either way you do it, you get 65 ways. So this is one of those ways that if you remember that you can subtract what can't happen, versus adding all the ones that can happen. I honestly, when it's only 3 things to add together, I don't know that there's a lot of benefit into using the inverse method, but that is, of course, your choice. You get to the same answer both ways. Probability is the likelihood of a particular event occurring. This is not unfamiliar to you. Possible values of probability, we can use percentages or we can use decimals. We can also use it as fractions to demonstrate either the decimal or the percent. Just a couple of definitions. A trial, one set of actions in an experiment. Probability experiment, the act of conducting a series of identical trials and recording the results. You're going to be doing this in a bit. You're going to flip coins. Outcome is a possible result from one trial. Right? If I'm flipping a coin, I can have a head or a tail. There are 2 possible outcomes. Sample space is the set of all possible results from one trial. So this depends. If I'm flipping a coin once, that means that my sample space is a head or a tail. If I flip 2 coins, that changes my sample space. The random variable, what is to be measured and recorded, and this is a numerical value. And the event is the particular value of a random variable that you're looking for. So here's a scenario. We've got John planning to perform a probability experiment by tossing 2 coins 100 times in order to determine his experimental probability of flipping 2 tails. He records the number of tails. So the trial is flipping 2 coins and recording the number of tails. The probability experiment is we're going to do it 100 times. The outcome, I can have 2 heads, I can have a head and a tail, I can have a tail and a head, or I can have 2 tails because I'm tossing 2 coins. My sample space is it written in set notation. The random variable is the number of tails. So I can have 0 tails, I can have 1 tail, or I can have 2 tails. And the event that I'm looking for is flipping 2 tails. In class, I had you guys do this together. I'm going to provide just some data here from another class, so that we have some data to fill in here. So here's just a very small sample of 5 people tossing 2 coins 20 times and recording the results. So we had a total of 100 tosses. And of the 100 tosses, 30 came out 0 tails, 51 1 tail, and 19 2 tails for an experimental probability of 0.19 or 19%. Just some more definitions. So the sum of probabilities of the sample space has to equal 1. So in that last experimental probability, we had a 0.19 chance of getting 2 tails, which means we had a 0.81 chance of not getting 2 tails. See how they have to add to 1. Statistical fluctuations in quantities derived from many identical random processes are unavoidable. This is where we get into the terminology of whether or not it is statistically significant. We will discuss that more later. But over a large number of trials, statistical fluctuations tend to cancel each other out. This was only 100 trials. If we had done 1,000 or 2,000 or 10,000, the experimental probability gets closer and closer to the theoretical probability. And of course, the theoretical probability of two tails was 1 in 4. And so the theoretical probability is 25%. We had 19%, that's not too bad. We get the theoretical probability based on our sample space, or the total number of things that could happen, and the equally likely outcome that what we are experimenting for would happen. So the probability of flipping two tails, where A is the number of outcomes in which event A can occur, and S is the total number of possible outcomes. Remember from a couple of pages ago where our sample space was heads, 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 tails, tails, heads, or tails, tails. So that is 4 possible outcomes, or our total number of possible outcomes is 4, and then one of those is tails, tails. What is the probability of rolling a sum of 5 with 2 dice? Well, in order to do this, we're going to set up a table that shows what all the outcomes are of rolling 2 dice. Once you have that, you can see that the sums follow a pattern along a diagonal. And so there we have all of our sums to 5, which means there are 4 of them. So the probability the number of occurrences, so our NA is 4. Our whole solution set is actually 36 because we have a 6 by 6 grid. So our total number of possible outcomes is 36. So now the probability of rolling a sum of 5 with 2 dice is going to be 4 over 36. And of course, you're going to reduce that to 1 over 9. So the probability of rolling a 5, which is why I have P with the 5 in the brackets, because 5 is the outcome that we're looking for, is 1 over 9. The next question, what's the probability of rolling 1 5 with 2 dice? Well, now we're going to look at where are all the places on this chart where we have a 5. So I've highlighted the 2 rows where there is a 5 as one of the dice outcomes. And so we've got, so the total number of times when a 5 appears are 11. However, remember, we only want 1 5. So we're going to subtract when we get 2 5s. We haven't changed our sample set, so we still have 36 possible outcomes. The number of possibilities of 1 5, we have 10 of them, so the probability of rolling 1 5 is 10 over 36, or 5 over 8. Sorry, that's 18. So to write that as a probability, either as a decimal or a percentage, we've got the probabilities 0.278 or 27.8% probability of rolling 1 5 with 2 dice. Now, what is the probability of not rolling a sum of 5 with 2 dice? Well, you can think about this in 2 ways. We can just go ahead and count the number of sums of not 5, or we can think back to that the sum of all probabilities has to equal 1, and we already have the probability of 5 occurring, so we could subtract that to get the probability of 5 not occurring. So here we have the direct method where I can count up the number of ways I don't sum to 5, which is 32. And so the sum of it not being 5 is 32 over 36, otherwise known as 8 over 9. Or I could do the indirect method, which is the probability of it not happening is 1 minus the probability of it happening. So the sum of it not being 5 is 1 minus the sum of it being 5, and we know the sum of it being 5 is 1 over 9 probability, so 1 minus 1 over 9 is 8 over 9. Again, you can get to the same place just from coming at it from 2 different perspectives. So here is the equation that I showed you before, that the probability of something happening plus the probability of it not happening must add to 1. And so that means that the probability of something not happening is 1 minus the probability of it happening. A game involves rolling 2 dice. Player A wins if the throw totals 5, 7, or 9, and B wins if any other total is thrown. Which player has the advantage and why? So we're going to have to build another one of those tables so that we know what all the sums are. I'm going to highlight all of the totals of 5, 7, or 9 in one color. And when we add those up, there's 4 plus 6 plus 4, so I have 14 ways for player A to win. Again, the total number of options for sums is 36. So the probability that A wins is 14 over 36, and the probability that B wins is 22 over 36. What if we change? So here in this case, player B has the advantage because they have 11 of 18 chances to win, where player A only has 7 of 18 chances to win. So now suppose the game is changed so player A wins if he has 5, 7, or doubles. So I'm going to change what we've got in our chart. Now we've got a few more ways for player A to win, so we can count those up. So player A now has 16 chances to win, but player B still has 20. So player B still has the advantage. So we have narrowed the gap on player A versus player B winning, but player B still has a slight advantage over player A. And now you guys can take the time to work on some of your practice questions.